Alright. So once you're done doing the repo, just look up so I know where I can begin. Anyone still facing any issues? No? I'll give you a couple more seconds and then we can begin. Alright, so let's begin. So today, what I'm going to talk to you about is called Tensorflow. I explain to you why it's called Tensorflow. And today we're going to specifically focus on the JavaScript API that Google has provided us with. So let's begin. So this is the link for any of you who still haven't closed my repo. Just head out to tinyurl.com/mc-tensorflow. Okay? Alright, so a bit more about myself. I'm also an engineering student, studying computer engineering, second year. And currently I'm an intern at Dyson, machine learning intern. And I have two startups. First one is Healthkey. It's a European healthcare startup. Second one, it's a Germany-based energy startup. So if any of you are interested in entrepreneurship or applying machine learning in the space of whatever, just you can come find me later. Okay? Okay, so this is the scope of what we're going to do today. Firstly, we'll introduce to you deep learning, a bit more about, say, a history of it, and then move on to something called CNN. It's called Convolutional Neural Networks. You understand more about it after this. And after that, based on the knowledge of deep learning and CNN, I'll then move on to explain to you some of the basic functions and operations available in Tensorflow Js. And after that, we'll go to a demo, a really cool demo, on transfer learning. I'll explain to you guys what that means as well later. Okay, so the first thing. So, can anybody tell me what this is? Just shut up. Let's make this active. I know it's a Saturday morning, but let's be active. Because it's going to get dry pretty quickly. Okay, close enough. Yeah, so this is an image, right, that any machine learning algorithm today can detect as a dog. But the problem comes in, right, when you have something like this, right? So what is this? Is it a human or is it a dog? I don't know. It's been difficult for computers to tell today. And that's why recently, right, over the past 20 years, a lot of people have tried to replicate the human brain because the human brain is really miraculous. You are able to tell it's a human being with a dog face and stuff like that, right? But a computer is not able to do so. So what they go about doing in deep learning is this. So before we go to what deep learning is, machine learning, right, at this moment has two big branches. One is the classical algorithms, things like, if you ever heard before, it's like things like deep forest, SVM, all these mathematical algorithms that you can probably Google. But the machine learning algorithms that have been really popular lately in the past 10, 15 years are the class of algorithms called deep learning. And the reason why it's called deep learning is something I'll go through in a bit more detail later. But what we need to know is this at the moment. Remember I told you we're trying to replicate the human brain as closely as possible. So what we're going to look at today, I think it's called neurons. For all of you who have done biology before, you can recognize the top, what you see here, right at the top is a typical neuron in the brain, discovered by neurons like this. And then what we're trying to do is replicate it, and here's how we're replicating it. You see, basically a neuron has an input-output and some processing function. So you can just take it that if you pass some inputs, you're expecting some kind of output. As simple as that. So a bit more in detail about neuron. So if you look at a neuron, it looks very complex, but what you need to know is this, very simple. You have two inputs, input 1, input 2, x1, x2. You pass it into this thing called a neuron, which is basically a mathematical function, right? And then it gives you an output. That's fundamentally what machine learning is. Okay? So now, if I have a couple of these neurons together, all you have is a neural network, right? So you have input nodes. So all of these nodes here, right, are essentially what you see here. So you take all these circles, all these functions, and put them together, you get a neural network. And this is specifically called a feed-forward neural network. Very simple because the direction is in one direction. It's going from back to front. That's why it's feed-forward. So there's no other direction. So they all headed towards one direction. So if you look at it, if you look at this picture, right, you can see that there's an input layer, hidden layer, and output layer. So input layer, you just pass in whatever inputs that you have, be it an image, text, or whatever not. And the hidden layers are, the objective of the hidden layer is actually to find some features. I'll explain more in detail a bit later, but just know that the hidden layers perform the computations, and then the output layer will give out whether it's a dog, cat, or what, based on the image. So that's essentially a neural network. So how do we make this into a deep learning? So deep learning, right, essentially is this. So you have a neural network, you add more hidden layers inside. And that's where the deep learning part comes in. So basically it's a deep neural network, you have a lot more layers inside. Right. Do you all follow so far? Very simple, right? This is a mathematical function. So now, among deep learning, right, there are a lot of neural network architectures, right? Things like RNN. RNN is a recurrent neural network. And today we're going to focus on convolutional neural networks. How many of you have taken linear algebra or have worked with vectors? Okay, great. So you all heard the convolution operation. So for those of you who didn't, right, it's essentially a multiplication, right? It's a very fancy way to say multiplication. So a convolutional neural network, right? So throughout this presentation, I want you to keep this image in mind, right? So whenever I talk about neural network, right, just think of these circles and lines connected. So if you go back to convolutional neural networks, there are four main operations. The first one is convolution. Next one is non-linearity. Explain to you what it is. All these are very fancy names for things very simple. There's thing called pooling and classification. So it's in this sequence. So let's look at convolution first. So before we do that, right, every image can be represented as pixels from 0 to 255. Agreed? So what happens is this. So you see a number 8 here, right? What this slide is showing to you is this. Every pixel has a number in the range 0 to 255 representing number 8. So this is the very first step. You take an image and then you convert it into pixel value. Because it's a black and white image, you only have one channel. Because channels are things like RGB. So there are three channels. So if you have a colored image, you have a red, green, and blue channel. But because it's a grayscale image, you only have one channel. Yeah. So now image can be converted into pixel values, right? From this, what you do is quite ingenious. So this is a convolution part. Remember the first main operation is called convolution. So the zeros and ones are essentially simplified for understanding purpose. But the 1 and 0 can be replaced with any value from 0 to 255. Right? Remember the picture just now converted to pixel values? So what the convolution is doing is this. So you have something called a filter. A filter is a yellow box there. It's a small box that's essentially sliding across the image. Right? At each point in time, you're multiplying the values to get a smaller matrix. So you're kind of reducing the image into a much smaller one. Okay? So that's convolution. Right? So in this example, what you see is when I take an image of this skyline, when you do convolution, what you end up with is that feature map on the right. Make sense? Yeah. So this is the operation of convolution. And like I said, because this is a grayscale image, you only have one channel. That will mean that you only have one channel. So you only have one matrix of like this. So you only have matrix of this. So if you have a color image, you have 3 times of this. One for red, one for green, and one for blue. Make sense? So far we covered convolution. So the next thing is called nonlinear rectification. Fancy name, very simple. You see the image on the left. What you see is there's black and white. So the black represents negative values, and white represents positive values. So rectification essentially just means you take out the negative values. So any value which is 0 or less, you convert it to 0. Anything above 0 is positive value, you just leave it as it is. That's the only thing that's doing here. And you want to find out why this is something that's to be done, you can go look it up. Yeah. So once you after you do nonlinear rectification, you do something called pooling. Fancy name, but very simple. You see the box 1156. What we're doing when you do max pooling, right, is essentially taking the biggest value over there. So 1156, you just take 6. And this is pretty ingenious because this reduces the image size even more. And the reason why I have to keep reducing the image size is because you want to make computations faster. If you have a lot, if your matrix gets bigger and bigger each time you do this computation, right? You need a lot of memory and you need a lot more computation power. So you want to reduce that. So you keep doing a lot of these steps to reduce the matrix and only take essential details in the picture. So after you take this, after you have done max pooling, you move on to something called classification. Sorry, the picture is very small. I think the resolution is very different from the computer and the main screen. But essentially what this picture is you take an input image. We do something called convolution. Explain to you what it is already. After that, you do something called nonlinear rectification, and then you get max pooling. So what you ended up with, right, is, if you can see, before the last 2 yellow bubbles, going to read what is inside, you pass it into this thing called classification. So after you have gotten all the key aspects of the image through the first 3 steps, you want to decide now whether, based on the features in this image, whether this image is a dog or not. Simple as that. So that's why you have the classification step. Yeah. Do you all follow what? Do you all follow what I've said so far? So essentially, what convolutional neural nets do really well today is to identify objects in images really well. And this has been a great improvement in the past 10, 15 years, right? Especially with Geoffrey Hinton. You can go look up who he is. He's one of the founding fathers of AI, as termed. Basically, he coined the idea of deep learning, adding a lot more layers to a neural network so that deeper it is. Because the idea is this: the more hidden layers you have, each hidden layer's purpose, in a way, is to identify a particular kind of feature. So if you look at this room, one hidden layer can probably identify this is a door, right? And another layer can probably identify this is a screen. And another layer can identify all of you sitting down here. So when you put all of these features together, then the neural net can then say that, oh, look, we're having a sharing session or we're having a presentation based on these different features. So that's the idea of having a lot of hidden layers. Make sense? Ken? All good? Okay, Ken. I know that was a really quick crash course, but let's move on to TensorFlow. Right, so before I explain to you what TensorFlow is, very basically, okay, don't look at all the code first. Tensors are basically vectors, matrices, right? So if you have 2 matrices, x and y, and you have an add function, so basically what you're expected to output is x plus y, correct? The reason why it's called TensorFlow, you'll be mind blown in a minute, is because each x and y are each called tensors, and then for you to compute data in x and data in y are moved through the arrows, through the add node and output. So tensor is actually flowing through the graph. Yeah, that's why it's called TensorFlow. Yeah. We all I thought you'll be mind blown. Never mind. I was pretty mind blown. I saw that. But yeah, so that's the brief idea about TensorFlow. But okay, let's not waste time and let's get down to coding. Okay, so you can open up whatever IDE you all use. I like to use VS Code. Okay, so once you have cloned the repo, right? So you will see. Hold on, give me a sec. Okay, so you will have a folder called Tensorflow Js tutorial, and within that, right, I want you to open up walkthrough. All there, and then inside there, right, there is this HTML file called Intro to TFJS, Tensorflow JS. Just open it. You'll just see nothing much to see here. Yeah. All you'll see is Tensorflow JS feature control. I want to also open the HTML page in text editor of whatever choice. In my case, I open it in VS Code. Right. Okay. So in your Chrome browser, just type in, just open up the console or developer tools. For those of you who are not sure how to do it, just follow what I do on the screen. Right. Just open the Chrome settings. Yeah. Just let me zoom in for you. Open Chrome settings. You go down, look for more tools, and then click on developer tools. So shortcut on the Mac is
okay, sure,
thanks. The shortcut on the Mac is Option Command I if you are using Mac. But if not, just open developer tools. Anybody lost? Everybody have Intro to TF.js HTML file open on Chrome, and then developer tools open. So once you have everything open, right, you should see this on your browser. Anybody lost? Okay, great. So you have the same thing. You have the HTML file open in a text editor, and you'll see this. You should see this. So loading TensorFlow JS is very good because TensorFlow JS, right, it's kind of optimized for browser usage. And the good thing about that is this, because you're running all your machine learning or whatever computation, right, in your client's browser. Client meaning your user's browser. So what that means is this. Firstly, there are no privacy issues. So whatever computation that we do, right, whatever images are taken from the user is all taken and stored in the user's browser. It's never sent over to your server. So computation is done in the user's computer. So that's a really huge plus point, especially with all the privacy issues. And the next thing is, what we're going to use is a very light version of a convolutional neural net. So a convolutional neural net, right, has different, because that's like a broad class of neural networks that kind of do with images, are really good at dealing with images. We're going to use a particular architecture that's catered for mobile usage. So it's called a mobile net, MOBILE-NET. So it's a special class of convolutional neural networks. So if you look at this page, right, what you'll see is the very first thing that we do is import TF.js. It's as simple as this. Once you do this, right, you're kind of good to go already. Okay, and then now let's look at some basic operations in TensorFlow JS. So whatever operations I teach you about in TensorFlow JS can more or less be found in TensorFlow, which is the Python API or C++. So if you are familiar with Python or C++, or more comfortable with that, you can always find the equivalent there. But just know what are the basic functions in JavaScript. So the very first thing we look at tensors. Remember I told you what tensors are. Tensors are essentially matrices. As simple as that for now. So if you look at the first function, if I just print this out, what you'll see is essentially the first line is you are setting up shape. So it's a 2x3 array. And then the tensor values take in 1, 2, 3, 4, 5, 6 with the shape there. So this is one way to declare a tensor. So if you print this out, just save this and then refresh this. Hold on. Actually, you can just comment out everything else. Quite important. So the very first thing, essentially you can just code out everything other than the first these 4 lines lah. Then what you'll see is we have successfully created a tensor, and you can see here there are 2 arrays. There are kind of 2 arrays inside, 1, 2, 3, and 4, 5, 6. So that's one way to create a tensor. Very simple, very basic, but it's very important because these are building blocks of what you can build using TensorFlow. Same thing. There's another way to define a tensor. Let's call it constant b. So if I comment this part out, and then just look at constant b, you'll see the same thing. You can do that for constant c as well. So the first 3 lines, a, b, c, are all tensors, but they're defined in different ways. So you can see b and c. Yeah. You all see? Yeah. So you'll see tensors b and c in the browser. These are all 3 different ways. The reason why it's different, right, is just your personal preference. The first one is you declare a shape, shape, and then you pass it in. Second one is you just put in the array as it is, and it will just read from there. It will infer the shape. The third way is to actually, for readability, code readability purpose, you have TensorFlow 2D. So this is a 2D array. You declare it beforehand. So whoever's reading your code will be able to understand what kind of array you're dealing with. Because at this scale, it's fine. But when your tensor goes bigger and bigger, like in the case of the image, it gets a bit more complicated to understand. So if you use this function instead, which is recommended by TensorFlow, it's better because whoever's working with you will understand what you're trying to do. Okay. And then of course, you have declaring an array of all zeros. Comment this out. Of course, no problem. Let's do this. So that's for creating tensors. Very simple. All you have to do is just tf.tensor. Tf stands for TensorFlow. And then next one, variables. So you have to understand, right? When you create a tensor, it's immutable. It means once you create there, you cannot change it. That's why you see all the declarations, right, are all const. So whoever's familiar with JavaScript, we all know that const, right, would mean that you cannot change a variable. It's just like static in Java, and not static. It's yeah. But yeah. So next one is variables. So if you look at variables, right, variables are the one that you can modify. So in the case for this example, right, I have initial values. Yeah, so I have initial values and I have change values. So in the case of a tensor, you cannot change it. But just show an example. If we have a variable called biases, and then we assign it the initial values, which is here. And then we can print it out. You'll see yeah. So you have initial values of all zeros, and this is because initial values is a tf.zeros. So I create a 2x3 array with all zeros. So now, if I were to reassign the variables with change values, this is something you can do because this is a variable. Then you can see that the variable changes from 0, 0, 0, 0 to 1, 2, 3, 40, 50, 60. Right. So those are variables, tensors and variables. Variables are mutable, tensors are not. Next thing, operations. So these are like the main bulk of what we're trying to do. So remember, like, when we talk about convolution or recurrent or whatever kind of neural network, right? It's essentially mathematical functions. How you put together things like add, subtract, multiply, square, all these kind of different functions, putting them together and then giving an output. So that's essentially what a neural network is. So if you look at operations, this is at the heart of TensorFlow. Very simple. I create x and y, 2 variables, 2 tensors. The first thing we're trying to do is we will now try to compute the sum of x and y. So the syntax is very simple. All you have to do is x dot add y. So you add x and y together. So if you look at the result here, you have 1, 2, 3, 4, and 5, 6, 7, 8. So what it will do is you will do, if you look at the result, it's 6, 8, 10, 12. So what it's essentially doing is we'll add 1 with 5, 2 with 6, 3 with 7, and 4 with 8. Straightforward. So we can do the same thing. Instead of add, we can change it to maybe subtract. And then you'll see, yeah, minus 4, minus 4, minus 4, minus 4. Because all of them are off by 4. And then you can also do square. So a square, the square function, right, it's a unary operation. That means you only take in 1. So you will do x squared compared to multiply, sub, and addition, right? These are all binary operations because you need 2 variables or tensors. So x squared will essentially, as expected, will give you x squared. So 1, 2, 3, 4, all the squares. So another good thing with TensorFlow is it allows you to do something called it has a chainable API. So you don't have to do addition and subtract in separate lines. You can add them together. So in this case, what I've done is to add x and y and then you square that value. So the result is as follows. Yeah. So you see x plus y and then you square. Yeah. Very basic stuff, but it's important before we follow on to the next part. Right. So far we've talked about 3 things, right? Tensors, variables, and operations. So these are like building blocks. And if you put them together, you can try to make sense of something called models. So in machine learning, when we talk about models, we're talking about, say, the entire neural network and different layers put together. So when you put multiple functions together, we kind of call it a model in the sense. And then this model just essentially takes inputs and outputs. So it takes inputs and produces outputs. So the output is what we want to see. So this is an example from Tensorflow Js tutorial. So it looks daunting at first, but essentially what we're trying to do is a simple math function. Y equals to ax squared plus bx plus c. To do something like this, right? Basically, we have a function called predict. And this function basically gives the output of this function, ax squared plus bx plus c. And then it takes an input, which is the input value, which is x. So what we do here is, if you notice, right, there's something called a scalar here. Because your tensor is a matrix, which is a vector, you always obviously have something called a scalar, which is your normal variables that we are constants. So all these x values are then passed in. So on this line is ax squared. So you do x squared inside the function, then you do a multiplied by x squared. So the same thing for ax squared bx. And then you put them together, you get y, and then you return y. I'll follow. Okay, so there's something here called TF tidy. This is something you will see again later during the demo. TF tidy essentially, right, is kind of like cleaning up your memory usage because each time you do this computation, right, there are a lot of variables, intermediate variables that are declared in between. And you want to make sure these variables are not used, are thrown away as and when they're not needed. And because this is very important, especially for computers like ours, they are not GPU, they don't have, most of them either don't have GPUs or don't have the computational power like servers. So this kind of optimizes for browser-based machine learning operations. So essentially that's a model, just a math function. And then let's look at result of this function. So in this case, what we have is we have declared A to be 2, B to be 4, and C to be 8. And then these values here, right, the constants, are then used in the predict function. And so if we pass in the value of x equals to 2, you should expect the result, if I'm not wrong, is 24. It's a problem when I use the same variable name. Yeah, so you get 24. You can press calculator to do it. But so these are like essentially using TensorFlow as a calculator. But you can do a lot more than that. But I'll leave that for you to find out. So this is basically the core concepts in TensorFlow. You can find it. This is taught to you in JavaScript, but you can also find this in Python or C++. So what you have seen so far: operations, tensors, variables. So later I'll highlight to you when we go through a bit more in detail as to what these different functions are. So at this point in time, let's close intro to TensorFlow JS HTML page. Do you all have any questions about what I've talked to you about so far? About TensorFlow or the basic operations? It's very straightforward, right? Yeah. So now what we're gonna do is I'm gonna show you a demo of what we're gonna try to build today. Right. So let's give it a bit of time to let it build. So yeah. So Yarn is basically a dependency management. So whoever's using Node npm, you can use npm install as well. So what we're trying to do now is I'll show you all the demo that we're going to go through, that we're going to try to build today. It's pretty interesting because what we're going to try to do is try to play Pac-Man with your head. Right? So if you turn left, then it will move left. If you tilt your head to the right, then it will move right. Let's just give it a couple more seconds. Okay. Right. So basically, this app right currently is a Node.js app. So you need to build it using npm or Yarn. But you can also actually, like just now in intro to TFJS, right? The HTML page. What we have seen is we have run it straight from the browser. We can also do that, but since this is a complex app, we need to use this. So this code, right, is adapted from Google's tutorial to suit our needs. So I'm gonna try to do it right now. Hope it works. Yeah. So. All right. So, couple of things that I want you all to notice here. Right. So if you look at the left, right, there's something called learning rate, batch size, epochs, and hidden units. Right. So first thing, let's talk about hidden units. Very easy. Hidden units is essentially your hidden layers. How many layers do you want to add? And remember, I told you what hidden layers do. Hidden layers try to find out for features that it's kind of like finding different features within the image. So we add more hidden units by right should have more better performance. But recently they've shown that it's not exactly the case. But okay, next thing is epochs. Epochs essentially, in front of epochs, let's talk about batch size. So for any function, right, you want to train the function, you need to pass in inputs or data. So data in machine learning, right, there's kind of multiple different kind of learning modes in that sense. First is called supervised learning. Supervised learning, basically you pass in data, and then you say, okay, look, you pass in images of 10 dogs, and each time it predicts it's a dog accurately. You say, okay, good. Then you just say this is a dog, correct? Then you kind of like mark me on the spot. So if you pass in maybe a cat, and then it detects the dog, then you say, no, this is not a dog, this is a cat. So you kind of correct it each time it runs. So that's kind of the naive interpretation of supervised learning. Second thing is called unsupervised learning. So you just pass in a huge data set, you just hope that it will work. In that sense, it's a lot more complex than that, but that's how it works. So you don't actually go and supervise at each step what's happening. And of course, there's a thing called reinforcement learning. So each time it predicts correctly, you kind of give it a reward. Say that, okay, you get 5 points. And each time it predicts wrongly, you say, okay, you minus 10 points. So it will kind of optimize its points that it gets. So it's called reinforcement learning. So each time it predicts, you go back and say you correct the weights and stuff like that. Right. So in this concept of training models, right, a batch size is essentially how many images are you passing it at one time. So when you run a model from start to end means right, you pass in an image and then you get a prediction, right? So that's from start to end. So a batch size kind of determines how many images within this data set. So when I talk about data set, it's like just a folder of images. So how many of these images do you pass into the neural network at one time before you change all the weights? Weights meaning, right? Okay, wait. So let's go back to this. Just show you the neural network again. Okay, so what you have is functions, right? You see the arrow? The arrow is connecting from one node to another is essentially like a weight. So you're saying, because if you look here, right? Yeah, this is a better representation. So yeah. So each of those nodes that you see in the previous image, yeah, like a circle, right? The arrows are essentially this thing called weights. So these are like something that you add in front of one weight. So if you look at the function below, I know people at the back cannot really see. That's fine. If a function say y equals to ax plus b, right? Your a there is kind of like your weight. So you kind of modify this weight, right, to get y that's of your desired. Yeah. So if you have, in this case, you have y equals to wx1 plus wx2 plus b. So your w1 is like the prefix of x1 and w2 prefix of x2 are essentially your weights. So your weights are actually your arrows. So if you look at this part, your weights are your arrows. So when we say we are training the neural network, right? What we're trying to do is try to find the right combination of values on those arrows such that when I compute the function, meaning if I compute the value at each circle multiplied by the arrow value, I'll get the desired output value. So when we talk about training, right, we're essentially changing this thing called weights. Does that make sense? You understand? Some of you are very confused. Understand? Okay? So when we're talking about training, we're talking about changing weights. So when we talk about batch size, right? When I pass in an image, what will happen is just not talking about passing one image. But usually what they do is to optimize, right? They probably send 4 or 5 images. The 4 or 5 is currently the batch size. Batch size is 4. I pass in 4 images through the neural network. Based on the desired output at the end, I know that maybe 4 of those variables have kind of predicted correctly. Then I go back and then change the weights respectively, so as to kind of fit this data. So I know if only 4 of the 5 predicted a dog, when all 5 of them are dogs, I need to change all the weights in this network so that the output is all 5 of them are dogs. Does that make sense? Yeah. So the process of going backwards and kind of modifying the weights is something called back propagation. Fancy name, but it's just going backwards and changing weights. Okay? So that is batch size. So when we talk about batch size 4, in a data set of maybe 100 or 1,000 images, we're passing in 4 images at a time, and then you go back and then change weight. So every 4 images, then you go back and change weight. Yeah. So that's batch size. So epochs, right? Essentially mean event. So batch size is every 4 images, right? So if my entire data set size is about maybe 1,000, or usually talk about millions of images, or tens of thousands of images. So we look at million images, right? If I have 20 epochs, it means that once I've run through all the 1 million images, I do that again. So 20 epochs means I'm running this 1 million images 20 times, right? And the batch size of 4 means every 4 images, I go change the weights. And once I hit 1 million images, that's epoch 1. Then I run that 20 times, the entire 1 million images. And there is a reason why we should run all the data set 20 times. The reason is, right, because each time you pass it, right, when you go back and then kind of change the weights, you will end up having this problem called overfitting. So like, maybe you have 10,000 images, right? You can't possibly detect say you have 10,000 images of tables. You can't possibly detect all the kind of tables in the world, correct? So what will end up happening, right, is the table that you try to teach it to identify, right, will be only this kind of table if all 10,000 images are this kind of tables. So that's kind of overfitting. You're kind of forcing it to detect this kind of table, but that's not what we want. What we want is to be able to detect any kind of table around the world. So running this over and over again, right? In that sense, kind of helps you. It kind of helps you find more features that you have missed through your previous runs of the entire dataset, right? So that's epochs and learning rate. Okay, so this is a bit more complex. Okay, so the thing is this. You have to understand, right? When we're talking about when we're talking about changing or training a neural network, we're talking about making, say, we have probability of 0 to 1. Usually that's how, so if you have something called a softmax function at the end, what it's trying to do is this. So if you have an image of a chair, right? Of course, right in front of me. If you have a chair, right? What the model usually outputs, right? It says it's probably 80% sure that there's a chair, right? But how does it know it's 80%? So this function called softmax amongst like different categories. So the idea now is this. This function, right, its objective is this, is to make sure that when you find something that's not a chair, you want to kind of reduce the loss. Like, because for a computer, it doesn't know whether it's a chair or not. What it's essentially trying to minimize, right, is something called a loss function. A loss function, right, essentially you can imagine it to be a grade, you can imagine it to be like maybe a valley of sort, right? Can you imagine a valley? So in a valley, right, if you reduce the loss function, you're basically at the bottom. So if you have like x square curve, right, your objective is to hit the bottom of x square curve, right? Right at the bottom. So if you want to hit the bottom of a valley, what you're trying to do is each time you run an image, you run through this training process, you're trying to minimize the loss function such that you're at the bottom for every category of images. So chair, tables, these are all called categories. So since your objective is trying to minimize this loss function, what this learning rate is talking about is your step size. So if we talk about my objective now, right, as a neural network through training is to get from where I am here to get to the floor there, right? But what learning rate kind of defines is at what step, what is the step size of me getting down? That how small is the step for me to go down? Meaning, I have steps there, right? 3 steps. So the learning rate over there is kind of big. So if in the sense that if I want to go from a higher place to a lower place, like go down this valley of a loss, I need to kind of determine how big of a step I'm taking at each time. So if my learning rate is pretty small, that means I'm taking very small incremental steps. Yeah. So that's what learning rate means. It's kind of helping you better train. So because the reason why it's significant, right, is if you have a learning rate that's damn big, what's going to end up happening is, imagine a valley, right? If you go all the way so close to the end, then your learning step is so big that you jump to the other side. Then you will never hit the lowest possible value. Because if you don't hit the lowest possible value, that means your ability to predict, right, is not that great already. It means your maximum probability in the sense of predicting a particular object wouldn't be as high. I said a lot of things, but does that make sense to you guys? TLDR, minimize loss function, right? To minimize loss function, step size is how incremental, how big is the step for you to kind of change such that the loss function is reduced. Okay? Yeah. Right, so those are the 4 things. So let's try this demo. Hopefully it works. Okay, so now without training, right, I'll show you guys how bad this system performs. So what you should keep your eyes on is the Pac-Man, the yellow thing there, and then me trying to get a high score. Yeah, that's the point. See if it works. Oh no, see, yeah, you can see that it's pretty horrible, and I died. Yeah, you can see it's pretty horrible in the sense that because right now this model is not trained. This basically the neural network that we're using behind, right, is called MobileNet. I talked to you guys about it earlier. MobileNet is basically trained on 1,000 classes all your normal stuff, things like water bottle, tables, chairs, a lot of different kind of animals. You can go look up ImageNet. ImageNet is like kind of this competition where they're trying to train this kind of computer vision based. It's a computer vision based competition. Trying to identify different kind of objects. So, but the thing is, it's not trained to detect my face, correct, in this environment. That's why it fails terribly. So let's try to train it. So to train it, right, we just have to add sample. Yeah, and then we just have to press train. So I might need your help to shout which direction I should go because I can't see. Right, so basically what I've done, right, I've added in like, you can see number of samples. So those of you at the back, basically I added like 59 samples of me looking left, 68 samples of me looking right, so on and so forth. So that hopefully it can detect me looking up, down, left, right. So we'll keep the basic kind of parameters, which is learning rate, batch size, epochs, and hidden units, because we are using very few samples, so it shouldn't really matter much. So let's just train this. Oh, it's fine, it's fine. The errors are normal. Because of different versions of TensorFlow. So let's try this now. Completes a bit more samples. But never mind, let's try coding it out first, then we can try again later. Right, so the idea is, ideally, if I think I need to add more samples, but that's the thing, right? Machine learning, a lot of things is just a lot of statistics, a lot of probability, a lot of trial and error. Yeah, so probably a lot more samples. It worked yesterday in my room, right? It was quite bright. I don't know, I think it was a bit hard to see. It's quite blurry. Right. So what we're trying to build today is this. Okay. Don't worry. A lot of things I've already given to you. So you just have to change basic stuff. Yeah, this is adding basic stuff. Okay. The key thing is here. So I talked to you about the neural network architecture that we're using. I keep using the word mobile net and CNN because I recommend that you guys go find out a bit more about different kind of convolutional neural network architectures. Because machine learning is more about understanding all the math first. Implementation is quite straightforward. Once you know what you're trying to implement. Right. Yeah. So here's the thing. So we have this thing called mobile net. It's trained on 1,000 classes, right? On tables, chairs, whatever not. What we're going to try to do today is perform something called transfer learning. Transfer learning is so if you look back again at this diagram, yeah, look back at this diagram, right? So in this case, it's very simple. We only have 3 layers. What we're trying to do today is we have many layers. What we're doing is we take the last 2 to 3 layers and we train only the last two to three layers. We keep everything before. Because ultimately, we still want to use the classes trained by the classes that the mobile net is trained on. So what we're trying to do is take the 1,000 classes and add our own classes on top. Okay? So to do that, all we're doing is take the last 2 to 3 layers and then we're just kind of training those last 2 to 3 layers. Because training the entire mobile net or convolutional neural network, right, takes about a couple of million images, and you got to run it for a really long time. Like on my computer, it will take days. Yeah. or probably orbital will be over by the time. Yeah, so that's what we're trying to do. It's called transfer learning. Yeah, so let's try to do that now. Right, so at this point in time, I hope everybody has cloned my repo, right? Anybody hasn't done it? Okay, cool. That's great. So once I've done that, I would like you guys to go into the folder, and then if you're using npm, then just type npm install. If you have installed yarn, go type yarn. And this will make sure you have all the relevant dependencies, because some of the dependencies are from Google itself, so you can't actually manually install them. So yeah, so I hope everybody has done that, because if you don't do that after this, while your friends are having fun playing with your head, that sounded wrong, but play Pac-Man with their head, right? Yeah, you guys won't be able to run it. Yeah. Okay, right. So today we're gonna change 3 files. We're gonna change, the first one will be the webcam, because we need to make sure, because each of us have different webcams, right? We need to make sure we take the center part, only your face in the webcam, and needs to be catered to each of your computers. So we have a script for that. Once you take the image of your face, we then have to collect all these images and then make it like a data set. So this will be a training data set, so that your model can train based on this data. Last but not least, we have index.js, which is your entry point. So this index.js is essentially running all your main components. So your train function, your predict function, these are all will be in the index function, index.js file. So these are the three files we'll be editing today. And then after that, hopefully some of you will have greater success in playing Pac-Man. Yeah. Right, so let's begin coding. Okay. Anyways, there's a lot of code to type, so I've copied and pasted it onto the GitHub. So you can head down to my repo, and then this will be the repo. So click on walkthrough. Under walkthrough, right, you will have Tensorflow Js walkthrough. If you scroll down, you will see this part on transfer learning. So this is essentially all the code that we need today before we run the Pac-Man game. Okay? So if at any point in time, you don't understand what I'm trying to say, just copy paste the code. I have put in // to do, so you just have to copy the right function into place. Okay? Okay, so are you guys ready? Are you all pumped to code? Because very dead. Is it? Okay, never mind. Okay, so let's do this. Okay, so everybody, thanks. So everybody, can you open up webcam.js? So the webcam.js is a webcam class. Basically, the thing is this. So for our neural network, right? This put aside all the front end HTML stuff. The neural network basically takes in a tensor. Remember I talked to you about what tensor is? Tensor is a matrix. So whatever image comes in, right, we need to kind of convert that into a tensor. So that's what we're trying to do here in webcam.js. So because I already wrote the code last time, I'm just not going to type it again. I'm going to copy the entire thing. So here what we're trying to do is, first thing is the capture function. Remember I talked to you about tidy? Tidy is kind of optimizing. Here what we're doing is, first things first. Before the back, can you all see this? Can you all see the code? Okay, that's great. Okay, so in convert function, first thing we have is a webcam image. So this webcam element kind of initializes your own webcam, and then it converts that into pixels. And then after we convert into pixels, right, we have to crop it, because each of our webcams, right, have different dimensions. But what we only need, right, is a 224 by 224 image. The reason why we need a 224 by 224 is because this mobile net architecture that we're using takes in an image of size 224 by 224. So this is kind of like image pre-processing. So whatever image size you have in your webcam, with a high-res image or whatever, it will kind of convert it into 224 by 224. So that's what we're trying to do now. And once you have an image of 224 by 224, because our image are colored, right? You have something called channel. Remember I talked to you about it, RGB. So you have the channel size will be 3. So you have like a tensor of size 224 by 224 by 3, because it's an image of 224 by 224 on R, G, and B. Right. So that's what you will get. After that, what we have to do is this thing called batch image, crop image, expand dimension. So what we're trying to do is, because the mobile net, this is the way the mobile net is kind of designed. It takes in a size. It will take in like one more dimension, which is 1 in this case, because you're passing in 1 image. So in this case, if you have maybe 10 images, you change this value to 10. Right. Okay. So this is the basic raw input that Tensorflow will take in, the mobile net architecture will take in. And what you have, so this is essentially kind of normalizing it. For those of you all who don't understand what normalizing is basically taking, because the image takes in a range from 0 to 255, what we're trying to do is convert it to 0 to, from -1 to 1. Yeah, it's just the way it works. Just take it as it is. If you want to find out more, you can talk to me later. All right. So that's first thing, just capturing the image. Very simple, very straightforward. Now let's go and, so if you all look here, right, there's this crop image function. This crop image function is something we need to copy, we need to kind of have here. And that's right here. Yeah. So crop image, essentially kind of taking your center. This is, no need to go through in detail. This is more or less quite straightforward. So we're basically copying the image, and yeah. So the adjust video size, right, is because the webcam gives you, like what I told you about, the webcam gives you different dimensions. We want to kind of standardize it in a sense for something that we can use. And we have the big setup class. Okay. Right. So the setup class, right, is actually looks very complex, but nothing much there. Basically, you're kind of initializing your webcam, and after that, once the webcam is initialized, what you do is you get your webcam's default video width and video height. So these parameters are important for us to determine where you are in the image. So we want to only take the center part. So these are all basic stuff. So with that, right, you're actually done with the webcam class. The webcam class will now let you have a tensor to pass into our neural network. Okay? All right. So moving on. Let's go on to controller dataset. So open up controller underscore dataset.js. So it should look like this for you guys. So like I said earlier, right, this controller dataset, right, essentially is to kind of control all the images, take all the images that you have passed in through the samples, and then create a dataset out of it so that your model can kind of train. Okay. So for this part, right, is actually pretty straightforward. Just copy this in. Okay. So what's happening here is this, right? So you see two inputs here, right? One is called example, and one's called label. Example is your face, right? Label is whether it's left, right, up, or down. That's important because what we're trying to do with the neural network now is, based on your face, determine whether you're in the up class, down class, left class, or right class. Based on that, whichever has the highest probability, that will then initiate the action in that particular direction. Right. So this add example class, you can see here. What's interesting here is this, because TF-tidy, right, is the way it works. TF-tidy kind of cleans intermediate variables. but we don't want the case in the case of adding our example. So when we add our images in, we don't want it to remove whatever images that you've used previously. You want the entire data set to be there with you, especially because when you're running the entire data set over and over again. So what we have to do is we have to add this keep tf.keep. What this kind of does, right, it kind of saves the memory. So if you're ever coded in assembly or C, remember you're initialize an array, and then the array, right, is allocated to memory, and then you kind of do memory manipulation. So here you're trying to say that, okay, whatever array of images I get, right, I make sure this is allocated a separate memory altogether. So it's not within the, like, it's kind of like not within what tf-tidy can remove. So this way you kind of keep all the images as persistent data. And yeah, the rest of stuff is quite straightforward. This is just keeping and concatenate the example. So whatever image that you have, you just keep adding. So you end up with a huge data set with all your images. And yeah, and with that, you're kind of done with controller dataset. Very simple, right? Just copy paste code only, right? But y'all just the most important thing for y'all today, right, is to kind of understand the overarching idea. If y'all don't follow any of the code part, right, it's perfectly fine, because I don't think a lot of y'all. How many of y'all code in JavaScript? Oh wow, it's really few. Guys, JS for the win. Okay, never mind. But yeah, but the point is, because a lot of y'all code in other languages, right? TensorFlow gives a lot of support, especially in Python, C++, and recently JS. So whatever concept y'all learn today, right, just keep that in mind, and then go look for the equivalent API in the language you're comfortable with. Okay? So yeah, that is that. So controller dataset is done. So let's go to the real deal. So let's open index.js. Right. Open up index.js already. Anyone needs me to slow down? Everything good? Okay. Okay, that's nice. Thanks. Okay, so this is essentially, I told you guys, right? This entire application is a Node application. So you will see some things that are very familiar. So in this case, we just have to import TensorFlow. So remember, when we use the browser itself, HTML code, we use a script, and then we pass in the source, which is TensorFlow JS. But in the case if we're using a JS application or Node application, we just have to import this as it is, and then we will be able to use TensorFlow as per normal. So in our case, like I said earlier, number of classes we have are 4, which is the up, down, left, and right. And then here we instantiate a new webcam class. So this will help us get all the images from your face, yeah. And then here you have this thing called MobileNet. Remember I talked to you about it over and over again? This is a compact, optimized version of a convolutional neural network that kind of takes in your image and gives you a prediction based on the images that you passed in. So the first thing we're going to do is initialize or kind of pass in MobileNet. The good thing for us, right, is because it's going to run a browser, Google doesn't expect us to actually have the mobile, to have the entire neural network together with your website code. So it's available for serving online. So what I mean by serving, right, is because this model has to sit somewhere, correct? What they have done today, a lot of these cloud platforms, is they have given you a link of sort, kind of like an API. You pass in this link, right? This will essentially run the model somewhere else, so that you don't have to kind of run it on your server, right? So that's serving. Now, okay, so let's load the MobileNet. To that, also very simple. Just scroll up and then copy paste. Okay, so here, all right. So over here you see, right, the very first line, loading the model is very simple. It's just tf.load model. The reason why I put await, right, you have to wait for it to load because you don't know when it will load. So yeah, simple as that. And then you can see here, for JS-based machine learning models that TensorFlow provides, they are all in JSON. So, So there are different kind of ways the model can be stored. One of them is JSON. There are other more optimized ways. I'll tell you all more about it, especially for those of you all developing mobile applications. How many of you are developing mobile apps? So few. Then rest of you are developing what? Websites. Okay, then this one will be pretty relevant for you. But yeah, so I'll share more about running on mobile. But yeah, so very simple. Once with this line, right, essentially we have loaded MobileNet. So all the explanation I gave to you about convolutional neural networks, right, are essentially just for your understanding. Loading the model is just as simple as one line, straightforward. Right. So once we've done this, right, we kind of need to tell our program which layer are we looking at. Because right, there are multiple different layers within the mobile net. It won't know. There's no like marking saying this is the last line, right? You have to go tell it. Okay, this I have maybe 10 layers. Amongst these 10 layers, I want to use layer number 10, right? So this is what you're specifying here, which is this line. The specific reason why it's named this way is because of the architecture. If we have time, we can actually look at the paper of MobileNet and see what are different layers available there and how it's optimized. So in this case, you specify what are the inputs, what are the outputs. Straightforward. Yeah. So then with that, right, you kind of loaded the neural network for us to run. And here this is basic up, down, left, right function for the HTML. What's next? What's important now is next part is the training part. So we need to give, so far what we've done, right? Webcam, take images, put in the data set, and then based on the data set, we have this function that they are mixing the data set. So what we need to do is write a train function. So when I click train, right, it got to train based on the images. So to do that, right, same thing. We'll just do this. Right. So in this case, right, what we're trying to do is here. Remember I told you about how we have entire mobile net, right? It means we have maybe multiple different layers. But of these multiple layers, what we will try to do is we will only train the last couple of layers. So for the last couple of layers, we kind of specify what those layers are. So in this case, right, the model we are training is specifically specified by using TF or sequential. So sequential means that it's sequential model. So that means what I'm trying to say is I'm going to add 2 new layers to this new model that I'm going to train. And this model has kind of two different layers. So what this happens, so these values here, how you get 77 and 256, right, is basically reading off. You actually have to know what the mobile net architecture is. So the output layer of the mobile net, then you just add this at the end. You just append it back. And to know what it is, you have to look at the paper. Yeah. So a lot of paper reading. So once you have done this, yeah, I think I missed one block. All right. All right. So I think for some reason the code on GitHub isn't updated. I'll push it up in a bit, but we need this learning part as well. So the first part, right, essentially is loading the model. The first part is identifying what are the additional 2 layers we're adding. So it's pretty obvious. So this is layer 1, and then we're adding layer 2. So this is defining the model we're training. And then after that, remember I told you about the loss function. So we kind of optimize based on the loss function. So you're trying to make it as low as possible. So that's what we're trying to do there is, what we wanted to do there is done here. It's called optimizer. And yeah, so if you all see this thing, it's called categorical cross entropy, another fancy name. So if you have 4 categories, what I'm trying to do is based on these 4 categories, we're trying to sort not sort. It's kind of put you into one of those categories. So essentially, that's what it's trying to do. So it's a loss function. It's basically a loss function for multiple categories. So we have four different items. It will try to minimize loss function for 4 different items. So this is something I should add in a bit. I'll just add that into. Give me a sec. I'll just open up. For those of you following, let me open up the README. Okay. So with that, with those two parts, right? Just give me a sec. I'll just add in the part on the missing parts. Right. So yeah. So what we have here is so far, yeah. So remember in the demo just now, we had like 4 different parameters: learning rate, we had the batch size, epochs, so on and so forth. So each of those values are passed in here. So here you add a get learning rate. This will kind of specify to the loss function how big of a step you should take while trying to minimize your loss. Over here, I explained to you just now already. Here is batch size fraction. So it's just different ways to look at it. Some people express it as a fraction of the entire data set. So if they put 0.4 in the case you saw just now, it means that 40% of whatever images you've taken, that would be the data set. That would be the batch size. So yeah. And then last but not least, we have the model fit. So you have all the parameters set up, right? So this is essentially what the training function is doing. So you try to make sure for each frame, meaning for all the images you passed in, you want to make sure you reduce the loss function. And that process of doing that is kind of called fit. So you're kind of fitting the model to the image data you passed in. Okay. So that kind of concludes the training function. So to recap, you just pass in all so you declare the additional 2 layers they're going to use to train. You're not going to train the entire mobile net. You're only going to train 2 additional layers. And then you have optimizer function. You kind of determine what's the learning rate for your loss function. And you determine what kind of a loss function you want to use. It means how do you want to go about reducing the loss. And of course, batch size, how many images you want to pass in each point in time. And last but not least, to conclude everything, for a training function, you have this fit function that takes all of these parameters together and then runs the model. Running the model is just passing through our images and kind of determine what will be the best outcome. So with that, you're kind of done with the training function. Let's look at this thing. Okay, I will just give me a while, guys. I will push this up so you can clone it again. And you can just pull. Okay. You have to replace the predict function. So just replace the predict function and the train function. Okay, so for those of you who are following, right? Just open up the terminal. You can just do git pull from if you have clone from the repo, and then you should have the latest. You should have most of the latest code I've typed already there. If you're not following, for those who are following, I've updated the page, so you should be able to see the missing code parts. So just for the train function, right? Just copy again the model TF6 show and put it into the train function. And then for predict, just replace the entire predict class. Everyone okay? All good? Right. So now let's look at the prediction class. So the prediction class is basically running when you press play. So that's why it's trying to predict based on the trained model. So simple, takes in the image from webcam class initialized earlier. So activation is basically the output of your predict function if your mobile net prediction. So your mobile net class, right, gives you a probability of the 4 classes. Remember you trained it for 4 classes, right? It will tell you which of these 4 classes has the highest probability. That's what we expect out there. So once you have gotten the predictions, you just put it as a, so at this point in time, right, it's just converted into 1D array and then argmax. So what argmax does here is this. So because the mobile net, right, it will give you probabilities of all 4 categories. So we have trained up, down, left, right. It will give you probability of each of them. So by doing argmax, you're taking the highest value of those and the corresponding label. So label here would mean up, down, left, or right. So once you've determined that, then you kind of know what action to take. So with that, you actually more or less should have a completely functioning demo. Hopefully it works for you guys. If you have copied the code correctly, it should work properly. For those of yeah. So wait for this. Yeah. So once this is done, right? If you type in yarn space watch, or for people who are using npm, right? The npm install, you run npm start, npm space start. You should create a local server, continue to localhost 1234, and that should be your demo that works. All right. So that's something y'all can play around with. That would be pretty interesting. But okay, the thing is this. Today, right, I know it's very rushed because it's a lot of things to cover. Because like things like machine learning, right, it's a very math intensive. It's not for everyone. So for those of you who caught no ball today, perfectly fine. You are pretty set on saying, okay, machine learning is not for me. Then also just ignore it altogether. Just know that there's something like that called Tensorflow out there, and it helps people deploy machine learning models. So I'll wait for that. Let's just let that run, and let's get back to some slides. Great. So what I have here for you all, right? I have a couple of different useful links for you guys. If you guys are interested in learning a bit more about TensorFlow and machine learning, I think today the objective was to get you all started. If you are interested to know about machine learning, you can always come talk to me, or you can drop me a message. Or you can also check out all these resources that I put up on the GitHub page. I think these are the most useful things that you should get out of today. So we have Tensorflow Js GitHub page, which is still under development, a lot of parts. So as and when you should see a lot of commits, and most of these are all open source. Tensorflow Js tutorials, a lot of what we've covered today will be there as well in Tensorflow Js tutorials. So that page will kind of show you some tutorials to get started. And of course, the big brother of TensorFlow JS is TensorFlow. TensorFlow, most of the APIs are all written in Python. So if you guys are interested, you're comfortable in Python or C++, you all can take those tutorials instead. And after today, how many of you are interested in convolutional? How many of you are interested in neural networks or machine learning? Okay, so if you are interested in computer vision based, right, there is this really good module by Stanford. It's called Convolutional, and it's CS231 and CS231. So if you click on the link, we'll bring you to the GitHub page. It's an amazing course. You should go definitely check it out. It's amazing. And for those of you all getting into machine learning, there is this crash course by Google. It's taught in Python, but the concepts are the same. So what I've taught you all today should be enough for you all to get started on the course. That's it. And for those of you who are more visual, don't really like to read a lot of stuff. I like to listen to people talk, right? There are two YouTube series. One is by Siraj Raval. It's a pretty cool guy. He gives really short clips. So if you all are very bored, right, listening to 2-hour lecture, 3-hour lecture, right, you can full speed this guy. Actually, not a bit hard. He talks very fast. But yeah, you can see his videos are very short, less than 20 minutes. One. To give you a short snippet of different things. So if you are interested in classifiers is basically what we talked about today. That's one. Then you talk about there is different things. He also likes to talk about blockchain and stuff. So if you're interested in blockchain or cryptocurrency, you can go check out his YouTube page. Yeah, pretty cool stuff. He explains stuff really well. Another guy you can check out is Daniel Schiffman on YouTube. He's a bit more random and a bit awkward also, but quite funny. Quite a funny guy. It's very interesting to listen to his videos. Same thing. These are short snippets. So if you all are looking to learn, I strongly recommend watching YouTube series first, because it's a lot more understandable. Because a lot of the documentation or research papers are catered for PhD level. So since you're all most of us here are all undergrads, it's a bit hard to understand because they just assume you know all the knowledge. So just bam, talk about all the high level stuff. And yeah, and this course, right, machine learning basics, it's a must. Everybody who wants to do machine learning has to do this course. It's taught by Andrew Ng. If you all know who Andrew Ng is, he is the head of machine learning AI at Stanford, and he's a chief scientist at Baidu. This is a course you must take. A lot of the concepts talked about today about batch learning and stuff, it's all taught here. He goes down even to the basics, because today I talked to you about deep learning, right? He talks more about classical machine learning algorithms. He starts from bottom up. So it's going to be tiring, very your brain will be drained after maybe 1 or 2 lectures. But it's worthwhile to pursue this course if you are even serious about having a career in machine learning or AI. So these links are all available on my GitHub page, the README at the bottom. So you should definitely check it out. Yeah, so these are useful links. And wait, let's see if it's done. Yeah, so if you all see these errors, right, no pre-GYP and all stuff, I just ignore them. It's perfectly fine. They're still trying to fix it. So if you guys have type yard and all the dependencies are installed, just give it some time. Should load. Yeah, just give it some time. Then with that, your app should be ready. Yeah, so y'all can try. I recommend y'all can just play around with these values. It's pretty user-friendly. You can just change these values. You can observe the different performance based on how you change these values. This is something for you to experiment and try. It'll kind of give you a better idea of what it means to change parameters in machine learning. And the truth of this, right, is this: like at this point in time, a lot of people have talked about things like deep learning, trying to replicate the human brain and stuff like that, right? But the sad thing is, even at this stage, we don't actually have a comprehensive understanding of how human brains work. At this point in time, right, it's quite amazing that a lot of us can just tell what things are from the peripheral vision, or even identifying, like an example I'll show you, a dog with a person with a dog face, right? That's something computers still have difficulties in processing, and our brain can just tell you in like less than a moment, much faster than computers. So a lot of recent developments in terms of machine learning research. Okay, just to give you an idea, right? This idea of convolutional neural networks is very, very old, about 20, 30 years old. So the reason why we're only doing this now, right, is because of a couple of different things. One is because we're able to get computational power. And you see, right, for me to train this, right, it will take really long time. So if anybody has trained models before, right, I can tell you that, just to give you an example, right, for me to train a complete mobile net architecture, which is supposed to be a thin version for embedded systems or for phones, right, I had a computer with 4 GPUs, 4 TI 1080 GPUs, and it still ran for 4 hours. Yeah, 4 to 6 hours. So you can imagine without 4 GPUs, right? How bad would it be? Right. So the problem is really that we need a lot of data, and our computation power is only now catching up with that. So that's why we're able to use things like deep learning today. But the issue is, if you go follow important people, so names that you should definitely record down if you all do record down. If you're interested in machine learning, you should record these names down. One is Geoffrey Hinton. He's a professor at University of Toronto. And what he talks about, he's the kind of guy who introduced the idea of deep learning, about adding more hidden layers. Right? His paper is a bit more complex, but it's the concept of saying, okay, look, if I have multiple layers, what I'll be able to do then is identify more features and then be able to make a better prediction. But today, the problem with deep learning is this. Deep learning, right? Like, remember I told you, like, all this training and stuff, right? You need so much data. Where are you going to get 1 million images of? How are you going to get 1 million images of yourself, right? By the time you take images, you think damn silly. You don't want to do this application or whatever anymore, right? So the problem is, we need a lot of data to make sure this model is accurate. That's one of like the key big problems. And this becomes a problem especially when you're running client side. So this is a huge plus when you're running browser side machine learning stuff. But still it's not enough. You see, like, there's no guarantee. That's not when I run it, it didn't really work as well. Right? It's not that the application sucks. It's just that the model needs a lot more data than we can provide at this moment. So that's like a huge problem. So if you guys are interested to know more about cutting edge research in this space, you can go check out. Go follow these few people. I can tell you the names, you just go right now. One is Geoffrey Hinton, I said earlier. Yan LeCun, he's actually the lead AI scientist at Facebook. Right, there is Andrew Ng, he's amazing. You should listen to all his lectures because he explains all the basic fundamentals of machine learning very well. And there is also Jeff Dean, he's the head of Google Brain, right, we're working on this kind of stuff. So these guys, right, are people you should really go and listen to see what the perception is. Because right now, right, the talk or the direction that machine learning is headed towards is not at deep learning anymore, because they realize that deep learning, right, this is a huge problem. Like, if you think about it, right, as humans, right, when we learn, do you get trained with 1 million images of flower before you can detect if it's a flower? No. You show you one flower, tomorrow I ask you whether it's a flower or not. You can tell very clearly whether it's a flower or not, right? So your brain works in miraculous ways. So the idea is now to move away and look at something called capsule networks. Capsule networks. So in short, it's called CapsNet. CapsNet, the idea of CapsNet, right, is to use lesser data but achieve the same performance as deep learning. So for those of you who are really keen on machine learning, you all can go check that out. Yeah. So yeah, so any of y'all got issues? How many of y'all can at least open this stage? Nice. It's great. Yeah, so y'all can go play around. I probably won't do the demo again. Y'all can go try out and see whether it works. And the key takeaway for y'all is really understanding key terminologies. We'll go through a brief summary after this. But yeah. Alright. So those are important people. Okay, so other useful links that we have that I would like to show you guys is so what I've talked to you about today, right, is something called Tensorflow. So Tensorflow, right, is usually tensors flowing. I'm still very mind blown by that. But okay, so another equivalent kind of library is called Piano. It's a Python-based library. It's pretty popular as well. And the reason why we do TensorFlow today and not Piano is because TensorFlow is one of like the biggest biggest communities, and they have a lot of support. And it's completely it's mostly open source at the moment, right? So this is another framework you can check out. Not as much support, but something worth trying. And for those of you interested in computer vision, like those of you who raised your hand just now about convolutional neural networks and computer vision. OpenCV is something you probably should have heard before. OpenCV is just open computer vision. So these are all machine learning algorithms, open source, that, not machine learning, it's computer vision algorithms, completely open source, that y'all can go and play around with. There are a lot of different things, but a lot of them are math functions. So if a lot of y'all, if any of y'all are interested in machine learning, but don't want to do math, right, I think it's going to be a bit hard, but still possible. Yeah. So it's OpenCV. And for those of y'all working on mobile apps, how many of y'all working on mobile apps? Or any of y'all want to integrate with machine learning? Integrate machine learning inside? No one. You're scary, is it? Okay, but if y'all want to, right? We have this thing. There's this thing called TensorFlow Lite. This is optimized even further for mobile systems, so embedded systems like Raspberry Pi, Android, iOS, and any other kind of microcontrollers. So it's optimized for that. If any of you are interested in how this optimization is done, you can come talk to me later. I can tell you how it's done. So this is something you can check out, TensorFlow Lite. For a lot of us, right, what happens is we don't have the computational power, so we might have to rely on using cloud services. So there are two cloud services I'll completely recommend to you guys for deploying machine learning models. One is, of course, Cloud ML. Cloud ML is by Google. The thing is they only let you try for free. It's not completely free. So yeah, so if you all want to spend some money, go ahead if you want to experiment. But the thing why it's good to use Google Cloud ML is because, have you heard of CPU? CPU? That's right. Like the CPU, right? Quite blur, right? Have you heard of GPU, right? GPU, graphics processing unit. And there's something called TPU, tensor processing unit. Right? So this TPU, right, is a special kind of thing that Google has created for their servers that's optimized to run TensorFlow. Right? So that's why Cloud ML is something y'all should definitely check out. It's worth checking out, but it's not free. So you can only try for free, so you can just play around with it. And the other one, definitely strongly recommend is AWS. It's like my favorite hosting. They're basically for AWS, right? A lot of common names you've heard before, like Tinder, Netflix, OpenAI. So these guys, right, all host the machine learning models and stuff, processes on AWS. So this is something you can definitely check out. This is a lot. There are a lot more free services that you can try out first. But if you want to like really high performance, I think Cloud ML still might be better. But I'm not sure of the performance. I haven't really tested Cloud ML versus AWS yet. But both should be fine for our use case of education purpose. So this is hosting cloud service, hosting machine learning models on the cloud. This is something worthwhile for you to check out. Especially if you're hosting any of the websites on AWS, right, there's really clean integration with their machine learning services and their hosting services. Right. Yeah. The next thing is this thing. So if you guys don't like to design all this kind of Pac-Man stuff, you just want to go straight into the math, right? You want to make this the real deal, find out right numbers and everything, right? This is something called TensorFlow Playground. This playground, right, is they forget about GitHub page. Yeah. So basically, they let you play around with data. Let me zoom in a bit. Yeah. So if you look at the top, if you can see, can you see? Okay, cool. So if you're whatever we have done just now, right, through JS code, essentially is done here, but this is more like a GUI. So you can change epochs, learning rate, activation, and from that. So activation, the value that you see, right? Value is basically remember just now the image that has two images, one with black and white, and just white only. So the value function is basically right, anything that's negative, you drop, you just convert it to 0. Positive, you just keep it as it is. Yeah. So that's an activation function. So you can change that. There are different things. There are things like value 10h, hyperbolic 10, and sigmoid function, so on and so forth. But yeah, so you can just play around with this. You can add more layers, so on and so forth. If you don't like to code, you can just play around with this and then determine the kind of data you have. So the output there is like it's a graph. For you to understand, make sense of the graph, you can probably read up a bit more on a different kind of graphs you should expect for a particular model, and then compare this with that. So this is a very neat way for you to just play around with parameters, so you don't have to keep typing and then changing and running and stuff like that. So once you have this settled, then you can take these values and put into your application. Okay? There's TensorFlow Playground for you. And then there is TensorBoard. For the people who are a bit more intense, TensorBoard allows you to analyze the model. So up till now, right, I've introduced to you something called MobileNet, but to you right now it's a black box, correct? There's an input, compute something, there's an output. If you use TensorBoard is a library that allows you to observe exactly what is inside the model. So remember, I showed you all this thing. The very beginning when I talked to you all about, I will talk to you all about TensorFlow. Yep, here. So at the top here, right, you see X, Y, and add, right? TensorBoard lets you see this for your entire model. So it kind of computes all your nodes and the graph. So you literally compute nodes and weights, so you can actually monitor what's happening by your training. So it kind of shows you the process of updating the weights and then back propagation, stuff like that. So it's pretty cool for you to observe. Right, that is TensorBoard. And the last thing I want to show you guys, right, is the CS231 and GitHub page. So the CS231 page is the one with all explanation. So if today, because I give you a very brief explanation of what convolutional networks are, if you guys want to find out more in detail, there's a complete explanation on what it is and a quite intuitive explanation as to how it works. And you can go check it out. I think it's difficulty loading, but never mind. You cannot load it then. You can go check out this thing. It's Convolutional Neural Networks, Stanford. And this should be good enough for people who are trying to understand convolutional neural networks. For the rest of you who want to know more about machine learning stuff, there are a lot more resources available online. You can just start with what I've shared on my GitHub. If you guys want to find out more about other stuff, you can always just Google them, you can always text me, right? And yeah, so you can always deploy the machine learning models using whatever, either on cloud or your computer or TF Lite. And remember I told you guys the key people in AI, I hope you guys remember who they are or take note who they are. You know who they are because these are people you definitely want to follow because these guys are really the people who are kind of navigating where machine learning is headed towards. Because the biggest worry with AI, one of the bigger worries with AI is back in the 1970s, 1990s, right? There was this period called AI winter because we've come up with all the evidence we can come up with, but our computers cannot take it. Our computers cannot process. So that was like, we had that phase then. So it's very important that we keep navigating through the right way. And I feel that we have a long way to go in machine learning before we kind of hit to the level of intelligence that we have today. So if you have friends saying, "Wow, AI is going to take over the world, AI is going to kill everyone," tell them, you know what, it's going to take a while. It'll be a lot better if you have understanding of where we are doing, right? We're just doing manipulations of functions. If you think that's going to be really smart, right? It's not. So if you just assure yourself that no Terminator bot is going to come kill you anytime soon. Yeah, I think with that, I'm done. You have any questions for me?